Sir is an assistant professor in the Department of Computer Science and Engineering at NIT Warangal. Sir has earned his PhD from IIT Hyderabad, MTech from JNTU Hyderabad, and before joining NIT Warangal, Sir was a postdoctoral fellow at ETS Canada, Academia Ciencia Taiwan, and as well as at IIT Hyderabad. His research area spans from image processing, machine learning, computer vision to deep learning. He has published a number of research papers in international journal and conferences of repute. He is also a member of various government-funded projects from DRDO and Department of Science and Technology, India. It's a pleasure to have you, sir, as one of the speakers to this workshop in the afternoon session. Now I request you to please share your knowledge with our participants, and sir will obviously talk about something related to what I have just told about. Thanks a lot, sir, to join this particular session.
Thank you, sir. Thank you very much for your introduction and your invitation. First of all, good afternoon to all the participants. So in this session, I will give some introduction about the unsupervised learning methods, and I will go for the one of the clustering methods. So that I will explain in this section. So basically, what is the difference between the supervised and unsupervised learning techniques? Any answer? I'm audible?
Yes, sir, you're audible.
Yeah. So basically, we have the different domain knowledges is there, like artificial intelligence, machine learning, and deep learning. Other than this one, we use the different terminologies also, like data science, text mining, speech processing, or medical imaging and computer vision. So what is the difference and why this many terminologies came? The main thing is, first one is how AI is there. What is AI? AI is nothing but artificial intelligence. It is the simulation of the human intelligence, how the human intelligence will work. Okay, like how the humans will be think, how the humans will be act, how the humans will be work. The same way they build the machines. The machines also work as the humans. Same way that will also think as the humans, work as the humans. Everything will be do like the humans. So that we can call as the machines. We can call as the artificial intelligence. So nowadays you can see many manufacturing companies, like car manufacturing companies, or maybe any computer manufacturing companies. So most of the places, instead of the humans, this robots will be involved to do the some kind of actions. So what type of actions? Maybe in that manufacturing they will do the welding kind of thing, or maybe assembling kind of thing. So how the humans will be do the same way, the machines also will work same like a humans. So that we can call as a AI in that case. So in this many things will be there in AI. So basically one of the part is called the learning part. Okay, so that we can call as the machine learning. So machine learning is the one of the application of the AI. So it is mainly used for, it will be give, we can give the past data. Based on the past data, what will happen, it will be predict the new data without explicitly giving any extra information. So only based on the past data only, it will be do the analysis and prediction kind of thing. For example, we are seeing the weather forecasting kind of thing. So coming 3 days, we have the more rains will come. How they will predicting? So based on the past information only, we have the only past information. We not have the any future information or extra information. So based on that, it will do the prediction kind of thing. Not only that one, in case of stock market prediction kind of thing, any other kind of analysis prediction kind of thing, that will be based on the past information. We can do the actions. So it is, I said, it is one of the application of the AI. So in this basically in machine learning, one of the learning methods we have basically that are classified as a two ways. One is the supervised learning algorithms, another one is the unsupervised learning algorithms. Okay, so these two are the learning methods only. Here in this supervised learning algorithms, many different type of the methods are available. One is the navigation classification method, decentralized based classification method, support vector machine based classification method, neural network classification based method. So one of the algorithm is called the neural network classification based method. So the extension part of the neural network is called the deep learning. So deep learning is the not the separate area kind of thing. Just it is the extension part of the neural network. Neural network is the one of the algorithm of the supervised learning algorithm. Supervised learning algorithm is one of the learning method of the machine learning. Machine learning is the one of the application of the AI. So ML is the subset of AI. All this deep learning is the subset of ML. So other than this one, different terminologies is there. So I'm not discussing about that one. Just we are looking to the, I know that mostly this session is related to unsupervised learning method. Okay. So here I will show the simple how the structure is there and what is the difference between the supervised and unsupervised learning methods and what are the unsupervised techniques is there. So I will explain like that one. So for example, your data is anything. So data is any form, like that is the images, we can call it as the image data. If it is the videos, we can call it as the video data. And documents, documents means text documents related or signals related. Okay, so the data is in the raw form. These all are a raw form. Then after that, we can extract the some information from the data itself. So that information we can call as the features or properties. Okay, so sometimes we have your data is directly you can extract the numerical data kind of thing. Okay, so that is also numerical data means it contains some attribute. Based on the attributes only you are extracting. For simple example, have the one red color apple is there, one yellow color banana is there. How to discriminate these two fruits? Any answer? How can you discriminate these two fruits? Based on the color or shape. For example, you consider the sweetness kind of thing. Okay. For example, first you are choosing your property is the color. Color is fine because the you are choosing the fruits. One is the red color apple, another one is the yellow color banana. So easily you can discriminate these two fruits because the color is one is red, is one is yellow. Next shape also it is helpful to discriminate these fruits because one shape of the fruit is round shape, another is the tall kind of thing. So easily you can discriminate. But what about the this another property that is called the sweetness of the fruits? So you can consider the sweetness of the apple or sweetness of the banana. Both are look like a same. Both are the sweet fruits only. It's not the bitter or it's not the sour kind of the taste. Both are the sweetness of the fruits only. Now you are choosing that this is your property. Really, it is helpful to discriminate these fruits. It's not helpful. So always you can choose your properties or attributes. Properties nothing but attributes only that need to give the unique information, and it will give the more discrimination information among the classes. Okay, so among the classes it need to give the more discrimination information. Then only that properties or that attributes are helpful to do the discrimination or classification or clustering kind of thing. Okay, so almost you can your accuracy of the your results of the your method depending on the most of the 60% of the case depending on your properties and your attributes only. Your properties or attributes is good, then it will give the better results irrespective of any other kind of procedures or any kind of the stages. But your properties is not good, your attributes is not good, it's not give the any discrimination information kind of thing. Even though you are using the best classification methods or best clustering methods also, it won't helpful to get the better results. Okay, so like this you can choose your properties. Different type of the properties already existed depending on the application, or maybe you can come up with the new application, new type of the properties. Okay, so I'm not discussing about the properties because it's a little bit not related to our topic today this session. So like that we need to extract the properties of each and every data. Then after you have the data, first you identify whether you have the label information is there or not. So label means, for example, this is apple, so the apple is the label. This is banana, banana is the label. So the labels are useful for uniquely identify the objects. We can use the labels. You take any data set, it has some label is there for that data. Suppose if your data set does not have any labels, then we can call as the unlabeled data. If the data contain the labels, then we can call as the labels information. So that is the we can call as the label data. If data does not contain any labels, we can call as the unlabeled data. Suppose you have the label data is there, you have the data is there, corresponding labels is there, then definitely you can go for the supervised learning algorithms. Where the data and corresponding labels is there, that we can call the label data, definitely you can go for the supervised learning algorithms. Suppose your data does not contain any labels, only data is there, then you can go for the unsupervised learning methods. In supervised learning methods also two types is there. Your data is continuous data, you can use a different type of the algorithms. Your data is a discrete data, you can use another type of the algorithms. So continuous data, you can go for regression models kind of thing. Discrete data, you can use the classification kind of problem. Now we are mainly looking to the this one, unlabeled data, unsupervised learning algorithms you are using. So what is internally going, how it is unsupervised learning algorithm will work, I will explain that one before going to that one. So main thing is your data is unlabeled data, okay, there is no labels, then definitely you can go for the unsupervised learning techniques. So for example, here I will consider the one kind of the example. Have the one box is there, okay. So in this box have the some bunch of fruits is there. So basically three different type of the fruits are available. So one is banana and apples and oranges. But here only data I am taking, there is no labels. I'm not giving this is a banana, this is apple, this is oranges, like that. I'm not giving any labels, just unlabeled data is given. Then I chosen the one person, so I given the task to him. The task is he need to separate the these fruits, okay. So you need to separate the fruits. So how can he separate? First of all, he don't know about these items. What is this item? Because it's unlabeled data. First he chosen the one fruit, that is banana, then he will keep separate. Next time he chosen another fruit, that is maybe apple, so he compare with the already separated fruit, that is the banana, so it's not matching up to that mark, up to some threshold, then he will keep separate. Next he pick the another fruit from the box, so that is maybe banana, then compare with the already separated banana and separated apple. So in this, which is will be more similarity will give. So similarity they will calculate it different ways. They will compare with based on some metrics or some measures. Different type of the metrics is available to compare the similarities. Euclidean distance, Mahler distance, cosine similarity kind of thing. So you can use any kind of the metrics to compare the objects, items. So in that scenario, what will happen? Next time he pick the banana, he compare with already separated banana, already separated apple. So in that case, what will happen? Which one is give the more closest one? Banana only given the more closest one, means more similar kind of thing. Then he will keep together. So next time he pick the another fruit, maybe it is apple related, then compare with the already separated banana and separated apple. So among these two, which is group will be more closest one, the already separated apple group is more closest one, then he will keep together. So next time he pick the another fruit, maybe orange related, and compare with the already separated banana, already separated apple group. So these two are not give the similarity up to the mark, then he will separate it as another side. So like this, he pick the one by one fruit from this box and compare with the already separated groups. So which is the more closest one, which is the most similarity one identified, then he will keep together. So like that, he form the fruits all keep together, form the groups kind of thing. Okay. So here he making the group, then this group is considered, he given the one name, that is called the C1, or any name is he need to give. He given the C2, he given for this group to C3. Then all the fruits is completed. Okay. Then finally you get the like these groups. So here what he's doing, he take the data based on the some similarity matrix, he compare the each and every object and he will separate it if he will from the groups, and each group contains the some name, that is called the group name. So these groups we can call as the clustering. Okay, so these groups we can call as the clustering. So what is the clustering? Clustering is nothing but is the process of grouping the set of data objects into the group of similar objects. What is the clustering? Clustering is the processing of what? Grouping the set of data objects. You form the group of set of objects. How you are forming the grouping the set of objects? Which are the objects contain the similar properties that you make it as a one group. So here you, in the C1 contains the what are the objects is there? All are bananas is there. So all are banana is there means what? All are contain the similar properties like same color, same shape, same diameter. So like that kind of the properties contained. If you take in the cluster 2, what is there? It is related to the apples related image, apple related data is there. So what is contained is the round shape and is the red color and is the diameter this much size kind of thing. So like this, based on the similarity objects you are forming the groups, then that is called the clustering. So here C1, C2, C3 are clustering. Cluster is nothing but that is clustering. Cluster is nothing but collection of the data objects only. Collection of the data objects. That is called the cluster. Okay. So here, what is going on internally? You are forming the clusters. Then entire clusters you are giving the name. Then what is going on? Here you are generating the clusters means indirectly you are generating the labels for the data. How you are generating the labels for the data? For example, here cluster C1 is contain the some objects. So all the objects in the C1, share the cluster name as the this object's names. Cluster names as this object names. So what is this object name? C1, because this object belongs to the cluster C1. This one C1 and this one C1. So what about cluster C2? All these objects share the cluster name as the object names. So this is C2, this is C2, this is C2. So this one C3, this object is C3, this object is C3, this object is C3. So indirectly you are generating the labels for the data with the help of these clusters. Okay, so clustering is nothing but is the processing of grouping the set of data objects into the group of similar objects. Where the similar objects is there, you make it as a one group. So that group we can call as the clustering. Cluster is nothing but collection of the objects only. So once you are forming the clustering means what you are doing, you are generating the labels for the data. How you are generating the labels? Which are the objects belongs to that cluster? The cluster name is shared by the all the objects. That is called the objects names only. That we can generate the labels. So this is internally going on the here clustering mechanism. So I said what is the clustering, what is the cluster. But here you remember it, once you are applying the some different type of the clustering methods are available. What are the methods is there? I will explain next. So using some method, some algorithm or some technique, okay, you form the clusters. You are using some technique or some method of clustering methods, you are forming the clusters. Then after forming the clusters, you want to verify it whether I formed clusters are good clusters or bad clusters. So you using some technique, you form the cluster. For example, I formed the 3 clusters. So this is cluster 1, cluster 2, cluster 3. Okay. So in this cluster, some 3 documents is there, here 3 documents is there, here 3 or 4 documents is there. Some 4 objects is there. So you form the cluster, this one. For example, the cluster name is C1. This cluster name is C2. This cluster name is C3. Okay. So like this, you form the clusters. Then after forming the clusters, you form good clusters or bad clusters. You want to quantify it. How can quantify? Based on the 2 similarity measures are available. So that one is inter-cluster similarity. Second one is intra-cluster similarity. So based on these 2 methods, based on these 2 techniques, these 2 similarity metrics, you can quantify your formed clusters are good clusters or bad clusters. Then how you can measure it, these similarities? So inter-cluster similarity means you select the one object from one cluster, another object from another cluster. You select the 2 objects. How you selecting 2 objects? one object from the one cluster, another object from the another cluster. Then you can compare these two objects. So when you are comparing these two objects, the similarity is more or less. Any answer? I'm audible? I'm audible or not?
Yes, sir, you are.
Yeah. So please participants, you can unmute and you can give your answer, no issues. So I selected one object from one cluster C1, another object from another cluster C2. Okay. Then I'm comparing these two objects. The similarity is more or less. How the similarity look like? If similarity is more, then what is the meaning of that one? Similarity is more means what? Both are similar or not? Both the objects are similar. If both the objects are similar, then why you are separated into the different clusters? Why you are separated into the different groups? Then your clustering mechanism is not good, not perfect. So your formed clusters are not good. So definitely when you are comparing the one object from one cluster, another object from another cluster, similarity always needs to give less. If the similarity given the less means what? Definitely your formed clusters are good clusters. So that's the reason your similarity is less means you are separated these two objects into the different groups. So when you are comparing the one object from one cluster, another object from another cluster, that similarity is called the intercluster similarity. So intercluster similarity means you are selecting the one object from one cluster, another object from another cluster, then you are comparing these two objects. That is called the intercluster similarity. So when you are comparing this one, similarity definitely you need to get the less only. If you are getting the more means, then your formed clusters are not perfect clusters, not good clusters. So always you need to give the similarity less. Next, another type of the similarity is, suppose you select the one object from one cluster, another object also from the same cluster. Then you are comparing these two objects which are belongs to the same cluster. Then you can tell me similarity is more or less. How the similarity look like? So definitely your similarity will get more only because the two objects belongs to the same group, same cluster. If that you are forming that the two objects are belongs to the same cluster, means you already checked that these two objects are similar. That's you are forming into the same cluster or same group. Okay. So definitely when you're comparing the two objects which are belongs to the same cluster, then similarity you need to get the more. If you're not getting the more means definitely that is the not the form the good cluster. So when you're comparing the two objects which are belongs to the same group or same cluster, then the similarity is called the intra-cluster similarity. So one is intercluster similarity, another one is the intra-cluster similarity. So based on these two similarity metrics, you can conclude your formed clusters are good clusters or bad clusters. Okay. So this is the one way of your rechecking your formed clusters are good clusters or bad clusters. So normally these clustering methods are used in many different kind of applications everywhere. So for example, marketing, they will use biological, medical related, they will use in the documents, they will use in the signals, they will use in the videos, they will use. So where you want patterns, you need to group it. Where your data objects are, you make it as a group, or you can form as a clusters. Definitely you can use this clustering methods. Means simply where you have the unlabeled data is there and you want to form it as a groups, then definitely you can use the unsupervised learning methods. So basically what are the challenges of this clustering methods is, the first one is you need to cluster the large data set. So this is one of the main challenging problem in the clustering. So why this is the main challenging problem is, so here you can observe it, most of the clustering methods, clustering techniques or clustering algorithms are comparison kind of thing. One to other objects you need to compare it. Your database contain the large number of samples is there, large number of objects is there. Then what will happen? Simply it will be very difficult to compare one object with other objects. It's more time taking kind of the is time complexity will be increased. So that's the reason you need to large data sets, clustering is one of the challenge. Second challenge is you require the fastness of the clustering methods. So what are the existing one is not sufficient. You need to build the new clustering methods that will give the more fastest clusters. You need to form it. So that way we need to build the clustering methods. So these two are the main challenging problems in the clustering approaches. Okay. So I said already the clustering methods are used in anywhere, many applications like marketing kind of thing or medical kind of thing or signal or maybe images are everywhere or documents everywhere. Or our real time also many applications we are using. For example, we have that insurance policies is there. Different type of the insurance policies are available like bike related insurances or car related or home related or life insurance related. In life insurance also different type of the policies are available. Jeevan Anand policy, Jeevan life policy, like that many things are available. So in that particular policy you need to know how many people is there. Okay, how many people contain this policy. Then you can apply the clustering method on that your data. Then finally you can get the some group of people. Okay, in the Jeevan Anand policy this many people is there. So like that you can get the information how many people contain this policy. So that is one type of the application. Another type of the application is the city planning kind of thing. So normally city planning, how you can identify some group of houses you can find out, then you can plan that city is like this is area is this one kind of thing. So here identify the group of the houses. How you are identify the group of houses means that is you're forming the clustering. How you are forming the clustering based on some kind of the metric attributes. Maybe you can take the house type, how the house type is there, how the house value is there, or land value is there, and geographical location. So based on these values, these attributes, these properties, you make it as a form the one group of houses kind of thing, means group of clustering kind of houses. Then you can plan the your city. So like that in any application in the communication or in software kind of places, or not only this one, in mechanical people, electrical people, any other kind of civil people where the unlabeled data is there, you make it as a group kind of thing, then definitely you can form the clusters. Okay, so here different type of the clustering methods approaches are available. So the first one is the we can call as the partitioning based approach. So here in the partition based approach means here for a given a samples, means given a data divided into the different partitions. Different partitions you are dividing means what you are doing the clustering. Partition is nothing but here clustering. Okay, so that approach is called the partition based clustering approach. So in this the famous techniques are k-means clustering algorithm and k-mediate clustering algorithm. These are the basic methods in the partition based approach. Next, another type of the clustering method is called the hierarchical based approaches. So in this hierarchy based clustering approaches, what will happen, it will follow the tree structure kind of thing. Maybe in the data structure you can learn the binary trees or maybe evil trees kind of thing. Like that, he is also hierarchical structure, means tree structure kind of approach it will be follow. So tree structure means it will be two ways you can do, either top to bottom or bottom to top. That we can call as the agglomerative clustering and divisive clustering. Okay, so like that we can use this hierarchical based approach kind of thing. So in this main clustering techniques are the bridge, rock, and Chameleon. These are the famous hierarchical based clustering approaches. Next, another type of the clustering approaches is called the density based clustering approaches. So in this density based approaches, based on the some connectivity and density functions, they will make it as the clusters. So in the particular in the sample space, they will take the particular density kind of thing. So within the density, how many samples is there, that all the samples will be considered as a one group, one cluster. So that is called the density based clustering algorithm. So in this case, the famous techniques are optics and Denclu and DB-SAN. So another type of the clustering methods are grid based clustering methods. So here they will divide the sample space into the grids. Okay, so like this, they have the sample space is there, they divide into the different grids. So already in the sample space means you have the data samples is there. So within the grid, how many data points is there, that all the data points is considered as a one group or one cluster kind of thing. So that is we can call the grid based clustering algorithm. So in this famous techniques are string, wave cluster, and click methods are very famous. Finally, model-based clustering algorithms. So in this model-based clustering algorithms is like a self-organization maps kind of thing, expectation maximization kind of methods will comes under the model-based clustering methods. So these are the different type of the clustering methods, and others also some little bit modifications came because this machine learning topics or machine learning course is not the fixed syllabus kind of thing, because this is the research oriented kind of the syllabus. So every person, they will come up with their own idea and they will build their model or their algorithm and show the better results than existing methods. But these are the basic clustering methods here, what I'm showing in the different type of the clustering approaches. So what is the clustering procedure content? What is the system architecture of the clustering? So system architecture of the clustering is nothing but first you are taking the data. So here I said data is any form, anything that is image related data or medical image related data or videos related data or documents related data or maybe signals related data, anything that we can call as the raw data. Sometimes they will collect the data directly, the extracted properties related data, attributes related data, they will take it. So once you have the data is there, next what you need to do, you need to extract the properties, that is called the feature representation. So depending on the your data, that related properties only you need to extract. What type of the features you are using, that related properties only you need to extract. If the image related properties, then image related, you are using image related data, then image related properties only you need to extract. Image related means that contain the color, shape, texture, this type of the image contain only image related properties. For example, your documents related data you are using, text document related. Text documents means what? It is contain the some content. Content is nothing but is contain the some words. Words is nothing but that they have the some special words is there that we can call as keywords. So based on the special words or keywords, you can extract the some properties. Or signal, if your data is a signal related, like speech related, you want to classify the whether that is speech or music related, or maybe it's in music also, different type of the music is available, you want to classify it like it is a pop music or classical music or rock music kind of thing. So how you can discriminate that one? So each one have their own properties, you can extract that related properties. Okay, so that is the feature representation. You need to extract the properties, and before extracting the properties, another intermediate stage is there, that is optional stage, that we can call as the pre-processing stage. So what is the meaning of pre-processing? Pre-processing means before your actual work, you want to perform some operations on your data. Before your actual work, task or actual work, you want to perform some operations on your data. That is called the pre-processing method. So before actual work means, for example, how the some ultrasound images is there in medical data. So how the ultrasound images, it is contained the full of noise information kind of thing. So in this image, you want to identify where the tumor is there, or where the cancer is there, or where the organ is there. You need to identify it. So because of this noise information, it's very difficult to identify it. It's not possible. Then so what will happen if you directly you can apply any technique or a method, you definitely will get the less results kind of thing. So to avoid that problem, first you need to apply the denoising methods. So denoising means you can remove the noise. Then after that, what you want to apply, you can apply the techniques to identify the tumor or cancer kind of thing. So actual task is what? Actual task is identify the tumor or cancer kind of thing. But what you're doing, you're denoising, you're doing on your data. So this denoising is the pre-processing method for your application. So this pre-processing method is not compulsory to all the applications. It is when it is any pre-processing methods also not fixed kind of thing. Many methods are available. So what type of the pre-processing method is required for your data, you can apply that related method. And it's not compulsory also. If it's not required, your data is clean, your data is good, you have the everything is there, then it's not required. So pre-processing method is the optional only, it is not compulsory. What type of the effect is there for to get the less results, then you can identify what is the issue is there in your data, what are the problems is there in your data. Because of that issues, that because of that problems you are getting the less results, then you can realize it, then that related kind of the solution you can provide on your data. For example, your application image related application, so you collect your own data, your own images. For example, one image size is 10 cross 10, another image size is 11 cross 11, one image size is 12 cross 12. So like this, you have the different sizes of the images is there in your database. You have the different sizes of the images are available. Suppose I'm extracting the properties related to the my image pixel related properties. Pixel means color related properties. I am extracting pixel intensity values related. So in that scenario, you are extracting pixel intensity values means it is the 10 cross 10 image. How many pixels is there? 100 pixels is there. Then what is the my feature vector size? 100 cross 1. And here in this image, it is how many pixels is there? 11 cross 11 means 121 cross 1 feature vector size you will get. In this case, 12 cross 12 means how many pixels is there? 144 pixels is there. Then your feature vector size is 144 1. So you want take the whole data as in the one matrix form, means you can all the features your entire database, your features data is how you can fit the all the different sizes into the your matrix. It's not possible because this 100 cross 1, this 121 cross 1, this 141 cross 4, it's not possible. So in that scenario, what you need to do before you are extracting the properties, you need to resize the all the images into the fixed size. Either this will be resized into 10 cross 10, or this one is resized to the 10 cross 10, this is also resized to 10 cross 10. So all the images you can fix into the resizing. Then what will happen? Your feature vector sizes all are equal. 100 cross 1. This is also 100 cross 1, and this is also 100 cross 1. Yeah, like that you can bring in all the images feature vector into the equal sizes. So this is your resizing image is also one of the pre-processing technique. So in the pre-processing technique, there is no fixed kind of methods. That is depending on the what are the issue is there in your data. That related kind of the solution you need to identify and you can apply on your data before your actual work. That is a pre-processing. Sometimes main methods, these clustering methods, or maybe other kind of methods, classification methods kind of thing also you can as a pre-processing technique. So then after pre-processing, then you extract the properties. Depending on application, you need to extract that related properties. Then after that, you can use the some kind of the similarity metrics or similarity measures. So based on the similarity metrics or similarity measures, you can make it as a form the groups kind of thing, clusters kind of thing. So you can use any similarity metrics on your data. Based on that, you can form the groups. So after similarity metrics, you are getting the some grouping kind of thing. You form the groups kind of thing. And before you're calculating the similarity metrics and after extracting your features, if you feel your dimensionality of your data, means your dimensionality of your features is more, then you can apply the dimension reduction method kind of techniques. Here you need to apply the dimension reduction techniques. Why you need to apply the what is the requirement of dimension reduction is, suppose you are extracting the properties is contain the more, the property size is more. If the property size is more means maybe the properties contain the any redundant information kind of thing or any noise information kind of thing. So because of redundant information or because of irrelevant information, noise information means irrelevant information. So due to this, maybe you get the less accuracy. So to avoid this problem, you need to apply the some dimension reduction kind of method. Different type of the dimension reduction techniques are available. So that is basically two types: feature selection kind of methods, feature extraction kind of methods. So that which is the different type of the feature extraction techniques are available. They use that some kind of concept is called the transformation projection kind of thing. So in that different type of techniques available, like principal component analysis kind of thing, independent components analysis kind of the linear discriminant analysis kind of thing. So any kind of methods you can apply to reduce the dimensionality. So this dimension reduction also optional, but you can observe it because of that irrelevant data, because of redundant data, you are getting the less results. Then then you will get the maybe less results. Then you can alert that time, you can apply the some suitable dimension reduction method. Then after that you can go for the similarity measure. After applying the similarity measures, what you are getting the groups. That groups we can call as the clusters. So like that you can get the groups. Each group contain the group name, that is can call as the cluster name, like this A, B, C. So which are the objects belongs to that group, that all are share the cluster name as the object names. So like that you are generating the labels for the your data. Okay, so this is the system architecture of the your clustering procedure or clustering algorithm. So have any queries is there still now? You can ask here also. Any doubts or any queries? Okay, fine. If no queries, any queries is there?
No, sir.
Okay. So other than this similarity matrix, well-known similarity matrix, equivalent distance and Mahavlov distance and cosine similarity matrix. Other than this one, some other kind of the distance similarities are available. So that is basically comparing the two different clusters. So that is separately they will available. The first one is called the single link distance. So single link distance means here basically you are comparing the two clusters only. You can use this similarity matrix. So single link is nothing but the smallest distance between the one element from one cluster, another element from another cluster. Then that is called the single link distance. So for example, you have the two clusters is there. One is cluster we can call as the Ki, another cluster Kj. So what is the meaning of single link distance? It is the smallest distance between the two clusters. So where it is possible, smallest distance means the closest points of the two clusters. The closest points means maybe one point here, another point is here. So this distance will be always give the smallest distance. So that is we can call as the distance between the Ki comma Kj. So this point is TIP, this point is TJQ. So that is the smallest distance means minimum distance between the TIP comma TJQ. So that is called the single link distance. So another type of the distance between the two clusters we want to measure, that is called the complete link distance. So that is called the complete link distance. So this is the largest distance between the element from one cluster, another element from another cluster. So that will give the largest distance. That will call the complete link distance. So for example, two clusters is there. So where is the largest distance is possible? You select the one object from one cluster, one corner, and another object from exactly opposite side of the another corner. Then only it will give the largest distance. So this is the cluster Ki, this is the cluster Kj, this point is TIP, this point is TJQ. So that is distance from Ki comma Kj is the largest distance means it is contain the maximum distance of TIP comma TJQ. So that is called the complete link distance. Next, another type of the distance is called the average distance. So average distance means the average distance between the element in one cluster with compare the elements of all other elements in the another cluster. Then take the average of that distance is called the average distance. For example, two clusters is there. So in this cluster 3 data points is there, in this cluster 4 data points is there. So this cluster Ki, Kj. So you can select any one data points from the one cluster and calculate the distance from the data points to the another cluster center, another cluster data points. Okay, then take the average of all distances. Then that is called the average distance. Okay, distance between these two clusters, then average of the TIP comma TJQ. So other than these three similarity matrix, other than these three, two more similarity matrix is there. That is called the centroid based distance. So centroid based distance is nothing but distance between the two cluster centers is called the centroid based distance. For example, this one cluster, it is another cluster. So this cluster center Ci, this cluster center Cj. So this cluster Ki, Kj. So the distance between these two clusters, how you can measure is the distance between the centers of the two clusters. So distance between the Ci comma Cj, that is called the centroid distance. So this distance we can call as the centroid based distance. Next, another distance is called the mid-height distance. So mid-height distance is nothing but distance between the mid-heights of the two clusters. So this is one cluster, this another cluster. So this cluster Ki, this cluster Kj. So this is the mid-height Mi of this cluster. This is a mid-height of Mj. So that distance between these 2 points is called the mid-height distance. So that is distance from Ki comma Kj equal to the distance from Mi comma Mj. So what is the difference between the centroids and mid-height is, centroid is not always a centrally located object, but mid-height is exactly centrally located object. So that we can consider as a mid-height object. So that I will show how we can take the mid-height objects kind of thing. So these are the different type of the similarity metrics used to compare the 2 different clusters, how these 2 different clusters similar or not kind of thing. Okay, so this similarity matrix used. Now come to the first clustering method, that is the partition-based clustering algorithm. So partition-based clustering algorithm means what? So in this partition-based clustering algorithm, for given a samples, then given a n number of objects is divided into the some partitions that we can call as the k number of partitions. Each partition we can call as the cluster. Okay, so that have the n number of objects is there. This n number of objects, how many partitions you are doing, k number of partitions you are doing. These partitions we can call as the clusters. But any clustering methods, you remember the one of the requirement is the number of clusters are always much less than number of objects. So you need to follow this criteria. You are using any clustering methods, definitely number of clusters are much less than the number of objects. For example, you are taking the n equal 100 objects is there, means the total number of data points in your data is 100. You want to make it k equal to 100 clusters. Any meaning is there? You have the 100 objects is there, you are forming the 100 clusters or 150 clusters, that is the meaningless. So this is not the correct way. So always your number of clusters is less than the number of objects. Maybe you can form as the 3 clusters, 5 clusters, 6, 7, 8, 9, 10, depending on the data. So always number of clusters is much less than the number of samples. This is applicable to all the clustering methods. But in this partitioning based clustering approach, it is have the specially 2 requirements is there. So you need to follow these 2 requirements. First requirement is each group, means each cluster must contains at least one object. So each group must contain at least one object. For example, you have the n equal 100 objects is the total number of data samples, and you want to make it as a 3 clusters. So you form the 3 clusters, 1, 2, 3. So here clusters C1, C2, C3. C1 contains the 50 objects, C2 contains the 50 objects. And how many objects is there in the cluster C3? How many objects contain the cluster C3? Any answer? Total 100 objects you taken, you are applying the any clustering method approach, and you form the 3 clusters. So 3 clusters are C1, C2, C3. C1 cluster contains the 50 objects, C2 cluster contains the 50 objects, and C3 contains how many objects? 50 plus 50, 100 is completed. Then how many is there? 0. C3 does not contain any objects. It is the empty cluster. Now check it. It is follow the first requirement. What is the first requirement? Each group, means each cluster must contain at least one object. Here anything is contain any object. There is no objects. Means it is contain the empty cluster. So the meaning of the first point is we not have any empty clusters. Definitely it is contain at least one object. At least one object means, for example, in C2 contain the 49 objects, or it is contain one object is there. Yes, it is follow the first requirement, because each group contains at least one object. Here 50 objects is there, here 49 is there, here 1 is there. Then it's fine. Or maybe the cluster C2 contains the 30 objects and cluster C3 contains the 20 objects. It's fine, because it is following the first requirement. So first requirement, what is telling? There is no empty clusters. At least one object is contain the cluster. Next, second requirement is each object
So we're
must
not able to see the screen actually. So
not see. Yeah, no.
yes, and now this is visible. Yeah.
Yeah. So second point is each object must belongs to the exactly one group only. So here I have the how many objects is there? 100 objects. See here, object is nothing but your data only. If the image data means 100 images, your documents is 100 documents. Your data is signal data means 100 signals. That we can call as the objects or samples or whatever it may be. Okay. So for example, here have the n equal to 100 means first object, second object, third, like this 50, 51, 90, 91, 99, 100. So like this you have the 100 objects is there. So first object is belongs to cluster C1. This is C3, C3, C2, C1, C1, C2, C3, C2. So like that each object is belongs to the particular cluster. Okay. So after forming the cluster, you are giving the that labels. Suppose the first object is belongs to C1 and C3. Then you can check the second requirement. It is satisfying the second requirement. What is the second requirement? Each object must belongs to the exactly one group only. It's not belongs to the multiple groups. But here first object you are pointing to the C1 cluster and C2 cluster. Then it's not following the partition-based clustering algorithm rule. Then it is not the correct way. So then either it is belongs to the C1 or C3. Then each object must belongs to exactly one group only. So when you are using this partition based clustering algorithm, these two requirements you need to follow it. Along with this one, any clustering of algorithm, you need to follow the number of clusters are much less than the number of objects. So these are two important requirements. Okay. So now we will talk about the partition based clustering algorithm. So first one is the k-means clustering algorithm. Okay. So in this k-means clustering algorithm is the one of the oldest clustering technique, but still at present days also most of the people are using this clustering algorithm other than machine learning background people. For example, you are in a communication related person, or you are in a software related person, or maybe another area algorithms related person, or maybe you are electrical related person, or mechanical related person, or civil related person, or biotechnology related person. So any person, they use the where they form the grouping of items means they use the mostly k-means clustering algorithms. So this is developed by the Maxwell in 1967. Okay. So this is called as the already this method also called as the center based technique. Okay. This is called as the centroid based method or technique. Okay. So now we'll see the how the k-means clustering algorithm will work, how it will do the clustering. So that I will explain here. So you can see that I am showing the that algorithm, but I will explain the each and every step clearly. So first you are taking the any algorithm, you need to take the input data and it will give the output. So what are the inputs are required for this clustering algorithm is number of clusters. How many clusters is required? So that is indicated the k, number of clusters. So total how many objects is there? N number of objects is there. This n number of objects we make it as the k number of clusters. So finally output how what you will get? You will get the k number of clusters. You are asking I need to do k number of clusters from the n objects. Then you will get the k number of clusters. So what is the approach is there? What is the method of doing the clustering is first to choose the number of k clusters and initialize the k number of centroids. Assign the each sample to the closest centroid based on its equivalent distance, and update the new centroid for each cluster using the mean of the assigned sample, and reassign each sample to the new centroid. If reassignment took place, repeat the step, otherwise stop the iterations. So these are the steps is there in the k-means clustering algorithm. Then I will explain the each and every step one by one. For example, how my data samples are like this in the sample space. This is my data. Okay. So this is my data. Total how many objects is there? 100 objects is there. So how many clusters I want to do? K equal to 3 clusters I want to form it. Okay. Now you want to make a 3 clusters. First point is what they're saying. Randomly choose K number of objects as the initial clusters. Initial cluster centers. So randomly choose K number of objects. K number of objects means how many total n equal 100 objects is there. In this you choose the 3 objects, that is randomly. For example, one object I am choosing here, another object I am choosing here, another object I am choosing is there. So remaining how many objects is there? 97 objects is there. So randomly 3 objects chosen from the sample space. Okay, that are initially considered as the cluster centers. For example, one object is there. What is the center of this point? One point is there. What is the center of that point? Any answer? The point itself, because one point is there, the center of the point is the point itself. So that's he saying initially choose the K number of objects that are the initial cluster centers. So initial cluster center means this is the point. So this point we can call as I am giving the label as a cluster C1. This is giving the label as a cluster C2. This point I am giving the label as a cluster C3. So that point is, what is the cluster C1 center is the point itself, because only one point is there, that we can call as the point itself. And cluster C2 is there. What is the center of the C2 is the point itself. So like that you can choose it. Next, randomly choose the any one point. Choose one object and calculate distance from the data points to the data point to cluster centers. So you can choose any one randomly one point, because 97 is there. Now I chosen the one point. Okay, the point is this one. Then calculating the data points to the cluster centers. So I'm calculating the data points to the cluster centers. So 3 clusters is there. You will get the 3 centers. Next, identify minimum distance. So which cluster center contains the minimum distance from that data points? Any answer? Participants, unmute and you can give your answers. You are choosing the one point randomly, this point, and calculate the distance from the data points to the cluster centers. Then after that you can identify the which cluster center contain the minimum distance, C1 or C2 or C3. So obviously C1 contains the minimum distance because it's closest to cluster C1 center. Then after identify the minimum distance, then assign the minimum distance center cluster label. Minimum distance cluster label to the data point. So which is the minimum cluster distance is there? C1 is contain the minimum cluster center distance. Then assign this data points to that label. So that label is C1. Then next, after that, you can update the center again. Why you are updating center? Because previously C1 cluster contained the only one data point. So what I said, what is the center of the C1 is the point itself. Now one more point came. Now 2 points contain the cluster C1. So what is the center of the C1 cluster? The C1 center cluster, how can calculate? You can calculate the mean of these 2 points. So you can calculate the mean of these 2 points. You can get the center. So mean of these 2 points will be give this center. Now center is updated. Center is here. So after updating the center, again repeat the same procedure until here. So remaining how many points is there? 96 points is there. Now randomly choose the any one point. For example, I am choosing the one point that is here. Then after randomly choosing the object, then what you are doing, calculate the distance from the data points to the cluster centers. Again, calculate the distance from these data points to the cluster centers. Then after calculating the distance from the data points to cluster centers, next what you are doing, identify the minimum distance which cluster is contained. So which one is contained? This point also closest to the cluster C1 center. Then assigning the cluster label to the data point. Now assigning the cluster label C1 to the data points. Now cluster C1 contains the 3 data points is there. Previously center is this one, but new one more point is kept. Then what is the center? For calculating center, again take the mean of the all of these 3 points. Then you are taking the mean, the center will come here. That is no previous center. So now center is updating. Now center is here. New center came. Now after updating center, again repeat the procedure. Remaining how many points is there? 95 points is there. Now again random choose the any one point. Now I am choosing the one point is here. Then calculate the distance from the data points to the cluster centers. Then I am calculating the data points to the cluster centers. Then after calculating the distance, then identify which is the minimum closest cluster is there. So obviously for that data points, closest cluster center is C21. Then assigning the cluster label to this data point C2. After assigning the label to the data points, next to C2 now contain the 2 data points is there. Initially this data point center is, this cluster center is that first data point itself. Now another point came. Then what is the center of this one? You can calculate the mean of these 2 points. Then you get the center. Now update the center here. Center is updated. So now after that again go 94 points is there. Repeat the same procedure for all the points, until all the points completed. So after all the points is completed, then what will happen? You can get the one cluster like this, another cluster like this, one more cluster like this with the center values. So final center values with it like this, you can get it. All the data points you can complete it. Then finally you can get the clusters like this. Okay, all the points completed, then get the clusters like this. My question is, my clustering is completed or not? 100 points completed. My clustering is completed or not? Any answer? I completed all 100 data points. I formed the clusters. Okay. Maybe I given the number also. This cluster contains the 50 data points. This cluster contains the 38 data points. This cluster contains the 20 data points. And after all the points, the centers are I given with the like a cross mark kind of thing. That are the centers. Okay. So your cluster form, your centers is there. Each cluster, one cluster contains C1 cluster contains the 50 objects, C2 cluster contains 30 objects, C3 cluster contains 20 objects. So my question is, my clustering is completed or not? I'm saying this is not the perfect clusters. Why it is not the perfect clusters? What is the reason why I'm saying it is not the perfect clusters? The simple thing is, for example, same thing I am taking, same data I am taking. Same n equal to 100 objects is there. So I want to make it as a 3 clusters. So randomly 3 data points I am choosing. One is here, one is here, one is here. So these are my initial cluster centers. So this is a C1 cluster, this is a C2 cluster, this is a C3 cluster center. Because initially the data points is the cluster center itself. So remaining how many points is there? 97 points is there. Suppose if I choose one data point here, and next to 97 points, one data point chosen, remaining 96 points is there. Now calculate the data points to the cluster centers, and which is the closest cluster center is there, you identify. And for example, in this case, which is the closest one? The closest one is the cluster C2. Then assign the label to this data point, it is a C2. Then update the center, now center is here. Now another data point I am choosing next time, this is here, now remaining 95 points is there. Then calculate the distance from the data points to cluster centers. So obviously this data point is closest to this cluster center. It is also closest to the C2. Then assign the label to the C2. Then update the center, then update the center is here. Now another data point I am choosing, that is here, and cluster calculate the distance from the data points to cluster centers. So obviously this data point is so close to the cluster C2, then assign the label C2, then update the center. Now center is here. So now I choose one more data point. The data point is here, and calculate the distance from the data points to the cluster centers. So this data point is closest to the cluster C1. Then assign the label as C1. Then update the center here. So like that, all the parts is completed. Now you are forming the clusters. One cluster is here, another cluster is here, another cluster is here. Now tell me, you chosen that this data point is initially. So now you tell me, after the all the points is completed, my centers are like this is there. So the C2 center is here cross mark, and C3 center is here, and C1 center is in the same place, or maybe here. You can consider here. Now tell me, this point where I am choosing the first time I am choosing the one point that is assigned as a C2. Now it is closest to the cluster center C2 or C1. It is now closest to the center C1. Then, but you are assigned this is as a C2. Why it is happened? Because that point is chosen the randomly. Which is the randomly chosen the point that is chosen initially you are choosing. Initially chosen that time cluster C2 is closest to the that point. But most of the C2 data points is in this direction. So most of the points in this direction means then what will happen? The center also moving in this direction. Mean also moving in this direction. If new point came, then center is moving in this direction. Okay. So most of the cluster C2 data points in this direction is there. Then if the point is in the direction is there, mean also moving in this direction. Mean also moving means center is moving in this direction. So after all the points completed, then what are the initially chosen the random point that is not closest to the cluster C2 now. It's closest to cluster C1. That's I said these are the not perfect clusters. Then what you need to do? Now again repeat for the all the objects. Now you are getting the center C is there. Again repeat for all the objects. Again it will be formed the some sort of the clusters, means some points is close. Now what will happen? This data points go to the cluster C1 this time. Now some of the points is going to another cluster. Again centers will be changed. Again repeat the steps for the some iterations, some more iterations, until how many iterations you need to do? Until clusters are converged. Clusters are converged means after some iteration, for example 89 iterations is completed, now 98th iteration. So after that you are now testing for 98th iteration, there is no change in the cluster centers. There is no change in the cluster centers compared with the previous iteration. If there is no change in the cluster centers means what? There is no data point is moving from one cluster to another cluster. When the centers will be changed, if any new point came to that cluster, then centers will be changed. If there is no new point come to the cluster, then center will not change. If the center will not change means we can say the clusters are converged. If the clusters are converged means you can stop your iteration. No need to do further clustering kind of thing. That are the final clusters. So like that you need to do iteratively this procedure, that is you can call as this clustering method is called the iterative clustering algorithm. They use another name called as the iterative clustering algorithm or center-based clustering algorithm. So why they given the K means clustering algorithm is it is the mean, based on the mean only it will be do the clustering kind of thing. So based on the mean only they will form the cluster centers, that is called the means, and K indicates the how many clusters you want, the number of clusters how many you want, that is given the K means clustering algorithm. Okay, so simply visually I will show here. For example, how they were my data samples is there. I want to make it as a 2 clusters. Okay, so I want to make it as a 2 clusters. So randomly I chosen the 2 data points that is indicated with the red points. So this is a cluster C. This data point is C1. This data point C2 because only one point is there in that cluster. So that is the center of its cluster itself. So remaining data points is there. And for example, you can calculate the distance, randomly chosen the one point. This point is chosen. This point is now closest to the C1 cluster. Then you can given this is as a label C1. This point is closest to the C2 cluster C2. Then after all the data points is completed, all the data points completed, now centers are here. These red marks are centers. Now you can observe it. So initially you can given this is as a C2. This is given as a C1. Now check it. This point is closest to the C2 or C1. So that point is closest to the C1. And this point is closest to the C1 or C2. This is closest to the now C2. Now that's I said these are the not perfect clusters. Again repeat the procedure where the centers is already have. Then again repeat the procedure. Then after repeating the procedure, then what will happen? You can observe it. This data point initially you can assign as a C2. Now it is assigned as a C1. The blue color point, light blue color points are belongs to the cluster C1, and navy blue color points are belongs to the cluster C2. Now you can check it this point. This is assigned as a now C2 cluster. So like that you can repeat this procedure, reassign until how many steps you need to do? Until clusters are converged. So once clusters are converged means there is no data point moving from one cluster to another cluster. Cluster centers are fixed. Then we can say that are the perfect clusters. So this is the k-means clustering algorithm here. And what are the drawbacks of the k-means clustering algorithm is? First drawback is, so where it is based on the mean only cluster centers are forming. Okay, based on the mean only. But where the mean is applicable, then only this method is applicable. If the mean is not existed, then this method won't work. So if any that such kind of data sets is available, okay, in that scenario, this k-means clustering algorithm will not applicable. So where the mean is applicable, then only this method will be work. That is the first drawback. And second drawback is you need to specify the k value in advance. You need to specify the k value in advance because it's the k-means clustering algorithm. You need to how many clusters you want. You need to specify before you are actually starting the procedure. So that is very difficult to you can specify the k value in advance. That is another drawback. And third one is it's very difficult to handle the noisy information, noisy data or outliers. It's unable to handle. For example, my sample space is like this is there. Okay, so this is my data is there. It is unlabeled data only. Suppose you can observe it here, all the positive related samples is there, one negative sample is there, here negative samples is there. So what is this sample? This sample you can call as the noisy information or outlier. Why you can call as the noise information outlier? Because all the surrounding points, all the nearest points is contain the positive points only, but this is only have the different properties. So which object contains the different properties among the all other properties is called the outlier or noise information. Then you are applying the any clustering technique, then what will happen? So based on the similarity matrix, you are applying this, all the data points is form as a one cluster, this all the data points is form as another cluster. So here what will happen? This outlier is going to the another cluster, C1 cluster, C2 cluster. So that's the reason it is unable to handle the outliers kind of thing or noisy information kind of thing. Or non-convex shapes also it is unable to handle this k-means clustering algorithm. So these are the main drawbacks of the k-means clustering algorithms. Okay. So have the any queries, any doubts is there, you can ask here. So any doubts or any queries you can ask here.
So are there any questions in case if anybody has a question, so they may ask, sir? It seems there are no questions, sir.
Yeah, fine. So if no questions, then we can go for the implementation of the k-means clustering algorithm. Now we'll
Yes.
show the demo kind of.
Yeah.
So Mukesh, you can start.
Thank you, sir. I'll be presenting you the k-means algorithm, the practical demo of it. Let me share my screen. Is my screen visible?
Yes, sir.
Okay, thank you. So we are going to use scikit-learn. So scikit-learn is something which has a lot of machine learning libraries. You can Google it simply, scikit-learn. So scikit-learn is the module which you can use for many of the machine learning problems, including clustering and like classification, regression, and everything is there. So this is one thing which you can utilize for most of your machine learning problems. We will be utilizing the k-means which belongs to the scikit-learn today to cluster our data. So this contains data classification algorithms, regression algorithms, clustering algorithms, and it is built on NumPy, SciPy, and Matplotlib. So NumPy is a numerical library, and SciPy is a scientific Python library. So they are used for numerical calculations, mainly the array and matrix and n-dimensional arrays manipulations like linear algebra things which are required in the machine learning and the deep learning domain. Those things are all provided by these NumPy and SciPy, and scikit-learn is built on top of that so that it is more user friendly. So you need not write codes from the scratch. So one more thing is I will show you. For example, I'll show you the Google News. So for what is the Google News? So you have a top story. So you have the columns right in the left side. So Google News is a typical example of clustering in the NLP domain. So natural language processing. So they cluster the articles. They automatically, the artificial intelligence of the Google classifies a document into a certain label. So here, you can see here is it can be a clustering problem, unsupervised learning. So it can cluster articles which contains a lot of data about India under the tag India. So it can cluster the articles which contain a lot of the world about the world, general world news. It can classify under the world. So in this way, you can think of the clustering problem here in this way. After clustering, they may assign a label for that, which is the most prominent label for that. So one of the clustering problems is k-means, as Srinivas sir has already explained. So what do we do with the cluster k-means? So in the case of k-means, we need points. We need uh, we need the Cartesian coordinate points, right? So what we do normally, if we have the features, we extract from the features. We can extract a representation, a vector representation of the features in n-dimensional space, and we can apply our k-means algorithms over that. So in this case, we will I'll show you the demo. So here I have taken the digits data. So digits data is actually a 8 cross 8 64 dimensional data. So what I have done is for visually representing the data, I have to show you visually how the k-means work. So I have reduce the dimensionality of the data using the principal component analysis, and that package is also available in the scikit-learn. So it's just plug and play. You can just relax and take advantage of the already work that has been done. So datasets also is available in the sklearn. You can see here the import. So this is the import. If you are coded in C or C++ or in Java, you might have heard about the include stdio.h and uh, extend import and those modules, mainly include and those things which we are using for header including, right? So similarly here the keyword is import. So we are importing the modules. These modules should be already installed in your system along with Python. Then you can import them using this construct. Normally we use import and the package name like import Python, and we can use an aliases. So as an NP. So why we need aliases? Sometimes every time you cannot try to numpy the whole numpy and then access those attributes and the functionalities in the numpy package. Instead, you can shorthandly use the np dot so that you can alias it here. Similarly, matplotlib is a visualization library which you are aliasing as PLT. So that's one thing. Then we have, you can see here another form of the importation is happening, like from. So from means for example, if I have a longer namespace, for example, I have to go into the scikit-learn, I have to go into the within the package, I have another module which is the data sets, and in that I have to invoke the function load digits. In that case, if I'm importing directly, then I have to use all these things, sklearn.datasets.load digits. So in order to use the load digits function alone, I can use an import like this from scikit-learn.datasets. I'm importing these load digits so that I can directly you can see the next cell, I can directly call the load digits instead of using the namespaces. The namespaces are like the folders which contains the files. In the namespaces are you need, if to access the file, you need to know the folder structure, right? So instead of that, you can directly give the file name or the module name if you are importing in this way from using the from and import statement. So these things are there. So what are the things we are importing for data sets? I'm importing the load digits data set, and for the dimensionality reduction, I'm importing the PCA, principal component analysis algorithm, and for clustering, I'm importing the k-means algorithm. Then for NumPy manipulations, I'm importing the NumPy package, and for visualization, I'm importing the matplotlib.pyplot as PLT. First of all, you need to run this cell. This is a Jupyter Notebook environment, like some similar to the Google Colab environment. So this one I have installed in locally Jupyter Notebook, and I'm running that from the command prompt so that I can access it through the browser client. So this is one thing. This you should have already installed, so that this is working. So I can shift enter if I press means I can run this cell, or else you can use a GUI tag run to run this cell. So you can see here, after running, it's imported and it's going to the next cell. Then I will run that next cell. You can see next cell is run, and then just for sanity check, I will check whether the data, what is the type of the data that I have loaded from the load digits data set, and what is the shape of that. So you can see here, it is a class NumPy ND array, n dimensional array. So n dimensional array is nothing but for example, you can have an n dimensional array like lot of vectors and matrices, right? Vectors are a one dimensional array, matrices are two dimensional array, tensors, those n dimensional arrays are called tensor. They are called ND array here in the NumPy, which may contain more than two dimensions also. So that those kind of, because the feature space is much rich in the case of machine learning and the deep learning algorithms, you may have millions of features or thousands or ten thousands of features. Each one has to be represented by a single dimension and a numerical value. In those cases, we are using the NumPy package and this basic object ND array to manipulate them. So you can see here that the type of the data is a NumPy ND array, and the shape of the data is 1797, 64. So the 64 is 8 cross 8 pixels of the digit data, whereas 1797 is the total number of images available. So we have a two-dimensional ND array. So we can have this here. So we can also, I will also show you a short demo of. So you have been familiar with Python. Do you know the concept of list? Can anybody respond? Do you know the concept of list?
Yeah.
No, right? Okay, so this is basically the list. So if I want to convert a list into a NumPy array, I can basically pass a list into a np.array. You can see here the list is being converted into an array. Why we need NP array means because the NumPy package is using is giving a lot of flexibility in dealing with arrays and the parallel processing that can be achieved in matrices. So, for example, see if I want to square each and every element of the array, I can do something very simple in this way. So you can see here, each and every element of the array is squared. If I have to do it in the list, either I have to use a list comprehension or for loop and so on, right? So that is not needed in case of an NumPy. You can directly do things like this, or else you can, for example, if you want to multiply each and every element by some factor, and also you can do that. It will immediately give results. So this is one of the advantage of NumPy arrays. And this being said, so we will come to see the other thing, which is the Pca fitting the transform. For example, if I am running the k-means algorithm on the k-means will work for n-dimensional points also. So it's basically the Euclidean distance, which can be extended to more than 2 dimensions. But for the sake of extendability and the visualization, I am reducing the dimension of 64 dimensional space to 2-dimensional space. For that, I am using the Pca algorithm. It's a principal component algorithm. So I will run this and show you. So this is okay. I think you can see here the result of the Pca algorithm when I invoke the type function and the shape attribute of that, it is giving me again the ND array is the same, the type is the same, but you can see the shape of the ND array being different. This time the rows are preserved, but the columns or the matrices are 2 instead of 64, which means it is a two-dimensional points. There are 1797 two-dimensional points, which is what we exactly need for k-means visualization, right? So that's being said, I'm just invoking the instantiating the k-means algorithm class. So k-means is a class, and I have to pass the number of clusters, which is a k. This is a k component. So as Sir has already discussed. So k is k. We need to know prior before starting the algorithm. That is one of the weakness of the algorithm also. So here, since the digits and total number of digits is 10 from 0 to 9, we already know the number of clusters. So we can give the cluster size as 10. So we can this is the k-means is the k-means is the thing we imported, right? See, you can see here sklearn.cluster, we have imported the k-means. So this is the class we are using to instantiate an object of the class, and we have to pass the number of clusters as the parameter. So you can see here k-means is done, and we are invoking the function fit predict. So this is one of the functions. So if you want to explore what is there in the k-means, you can do so with the help function of the Python, and you can invoke it on the variable k-means. So you can see here it is giving the manual or the documentation of the k-means. You can see the k-means is a module in the SK cluster k-means object, and the class you can see the class of k-means. So if you know the object-oriented way of programming, you might have heard about classes. So in Python also object-oriented is supported. So you can see here the classes are there, and you can see the parameter documentation of the class, number of clusters, you need random and those other parameters. Then you have other components as well. Attributes. So attributes, this we will use later. Cluster centers to plot the cluster centers, and then we have the labels, we have inertia and other things. So you can see so you can explore with the use of help function whichever thing you want to explore in your program. It's instead of going to the website and googling for that, you can use this as a shortcut of it. You can see here set there are many values, and I will show you. If you want to go to the GitHub repository also, you can go. So for example, if you go in the SkyKit language, you can see the GitHub repository is there. You can go there. You can see here the GitHub is there. So GitHub is the source code. So it is all open source, right? So open source, so you can contribute to this open source also. You can see here the datasets module is here, whereas our module is the k-means belongs to which one? I think it is, okay, 1 second. K-means belongs to cluster, right? Okay, you can see in the cluster. Okay, the cluster package is there. If you go there, you can see the k-means here. So this is the k-means that you will be using. This source code is the one that is running while we are invoking these scikit-learn functions. So you can, if you want to improvise on that, or if you want to fix some bugs of these things, you can always contribute to the open source community. You can see here k-means plus plus, and these are all the source code. So if you want to check the source code of how the algorithm is implemented, and if you want to say, if you want to improvise on the k-means algorithm, then you can refer this source code and can apply your modification on this, and then claim a paper or something. So you can see here, I can see here the class k-means. This is what we are using. So it has n clusters. This is what also what came in the help, right? When we typed help k-means. So, but the code is not visible in the help. If you want the code, you have to come to the GitHub repository. So this is the code. So this is the code for the function fit and predict we are calling, right? So this is the code. This is the one that will be running on back of the k-means class and the functions. So that is one thing. So we have the fit transform. I think we already run this. So yeah, we have run this also. So now you can predict the clusters and the values. You can see, you can just see what is there in the values. You see it's a list containing cluster size, cluster name that belong to each and every point. So you can see the length of this list. It is matching exactly with the number of points that we have given as the input, right? 1797. So that many. So it has classified 1797 points as, actually I should say it's clustered into 1797 points into 10 different clusters. So now you can see here, you can get the unique values from the clusters. For example, for that we can use an NumPy package. That unique function is there. It will return how many non-repeated objects, which means how many unique values are there in the list. So you can run this, and I will show you how many unique values are there. You can see here the clusters are from 0 to 9. Clusters are named from 0 to 9. So then we can see the cluster centers. As already being discussed, so the cluster centers will be the center of all the points that belongs to the particular clusters, that you can access from the k-means object and its attribute cluster centers. This we already seen. You can see here that this attribute is there in the cluster center. So you can see here one of the attribute in the k-means, which you can use to get the values of the cluster centers. I am running the cluster center. I am getting the values of the cluster center. Let's print and see what is there in the centers. All the centroids. You can see here it's a list of lists. So each element of the list contains two values. Again, a list, xy coordinates actually. So you can see the length of the clusters. It will be 10. See here there are 10 centroids. 10 centroids with xy coordinates. So then we have the points. We have the final cluster center of the points and the label that the clustering label that each point belongs to which cluster. Now we can use that information and leverage those information to visualize the output. So we can visualize them. For that I am using the matplot library. So what I am doing is, for each and every label in the label that is predicted for 1797 points, I am just using the scatter plotter. This is called a scatter plotter, which will plot the line, which will plot the points. So I am using the unique labels for 10 labels 0 to 9. I'm taking the this is like a array. You can do things like this. What it does, it label is equal to I. So if the label is equal to I, this will return a true values. Then if I pass that true values into an NumPy array, it will extract only the corresponding elements which are true, whose indexes are true. For this, I will show you a short demo to understand this. For example, let me say I am having a NumPy array. Say I'm having a list. It's already there. List is already there. Array is also there, I think. Okay. So I'll make use of this array. We have already built on array, right? So what I'm trying to do is, let me have a list which contains odd numbers. So let's say it is odd. You see here the odd numbers are printed. So what I'm going to do is, I'm going to form a list where okay, 1 second. Okay, this is a wrong example. I will give you some other example. Df is the whole array. Then let me say if I give label, okay, labels is also okay. Df label equal to 1. Let's say, let's see what I'm having. I'm getting an array, but what will be this array? So if you have label is equal to 1, what will be the value? You can see here it is creating an array with Boolean values. label is equal to 1. You can give label is equal to 0 and see that you can give the whole 10 digits, and you can see it's creating a numpy array which contains true or false. True means that position contains the digit 9. False means it does not contain the digit 9. So that is what this is going to give. So what I'm essentially doing is I'm going to give this as the index to the another empty array, which is the data points. Then what it will do, it will select only those rows for which the label equal to 9 returned true value. So in that case, you can see here how many points you can check. The length. 134 points are having the label as 9. So this is how you can use the power of numpy arrays. Simply you can use the comparison of one array to other instead of using a for loop or complicated logics. So that is one thing. So that is what is happening here. You are selecting only those labels which are classified as I. I means it can be from 0 to 9 from the array df numpy array. So in that I'm selecting only the first column, which means the array points has 2 columns, right? So which are you can see here contains 2 columns. Each value contains 2 columns. So I'm taking the x part separately by giving the comma and 0 column, and on the y part separately. So what I am doing is I am taking a list and I'm equating the list to a number, so that I get the true values and false values of all the indices, and I'm passing the true and false value array into another array, so that I get only the points where the label is true. And in that array I'm getting only the x coordinate and the y coordinate separately using the 0 and 1. This is the one thing. So you will have the x coordinates and y coordinates of each and every cluster. So each and every cluster will be labeled differently. So the label is from 0 to 9. You can see here in the legend of the matplotlib, the color is given from 0 to 9. So that is why we are giving the label. And then we have already taken the centroids from the k-means cluster attribute, right? This cluster centroids. So this variable we will again use it for plotting the centroids. So again you are giving the clusters and you are taking the x coordinate and the y coordinate. Here I am taking all the centroids. I am not filtering the centroids, right? Because I need not color them differently. I am just coloring them black. So in the previous for loop scatter, why I am filtering the each and every cluster, because I have to color them differently. I have to label them differently. So I am filtering each and every cluster's points, and then x and y point, and then I am passing it to the PLT scatter. So you can see here, if you run this, it will generate the visualization with colors and the centroids. You can see each and every color belongs to one cluster, and there are totally 10 clusters, and the clusters are named from 0 to 9 with the corresponding color code. So this are from my side. If you have any queries or questions, you can post it. If you have any coding questions or anything you didn't understand or anything I want to explain more, you can feel free to unmute or ask me.
Excuse me, sir.
Yes.
पाइथन प्रोग्रामिंग के लिए जुपिटर जरूरी ही है क्या? क्या हम गूगल स्कॉलर के ऊपर भी कर सकते हैं?
Sorry sir, I'm मैं हिंदी थोड़ा मालूम.
Okay, sorry. Sir, is it compulsory that Jupyter is always compulsory, or can we use Google Scholar also?
Google Colab, you mean?
For Python program. Sorry, Google Colab. Right, sorry.
Google Colab you can use. The only thing the Google Colab doesn't, the shift towards from Google Colab to Google Jupyter Notebook or your own IDEs like Spider or Anaconda and PyCharm is when you want to run for a long time. For example, if you want to, if your program, your deep learning model is taking 2 or 3 days to complete, in that case, Google Colab may not support you because they will refresh every notebook per 12 hours. Also, if your browser activity is not seen, they may refresh your session. In that case, you cannot run for a longer time. But if you have a dedicated GPU as a machine GPU machine in your lab, and if you want to run for 2 or 3 days continuously for some kind of vision problems or some bigger transformers, latest transformers are there, so you want to run NLP on them. You have a huge data set. In those cases, you can install Jupyter.
Actually,
Yes. Yes,
since
sir.
this session being started, that I have tried to download the Jupyter, but unfortunately I am not able to download it on my PC. Whereas I already had a Google Colab previously when I was attended one of the session. In that one, I used Google Colab. So I would like to know. So can I run this program in Google Colab also?
Yes, you can run. You can
Just a question.
SkyKit will be automatically installed in Google Colab, I suppose. If the Matplotlib, this thing should be there in the Google Colab, I think. So most probably you may be able to run from without any installations. If not so, you may have to install scikit-learn and Matplotlib alone, I think. I'm not sure, but the Google Colab environment should be having scikit-learn. So just the packages you need to consider, you can use it. You can simply do pip install scikit-learn or pip install matplotlib. Also you can use Anaconda for installing that Jupyter notebook. Na? You can in your system.
Okay, can you please share me the link?
Okay, for Anaconda or
Anaconda or Jupyter? What for any one of them? That
okay. So Jupyter means actually you need to have pip installed for Jupyter, or you can use Anaconda. Anaconda is better, I think. So Anaconda for Windows. And this is the one. So you can download here and install. I'll share this.
okay, in chat box. Okay, thank you. And very nicely you have explained that actually previously also I have attended a K-mean cluster algorithm, but there I have not seen means practical approach. But today I have seen the practical approach, and I like it very well.
Thank you, sir. Thank you.
I understood it very, very nicely also.
Thank you for your feedback.
Thank you.
Thank you. Any other queries are there?
Seems there are no queries, sir. So
okay, sir. Thank you. Then we lined up.
Yeah.
Thank you. Thank you everyone for listening. Thank you.
Thank you for a wonderful session, Srinivas sir and Murkesan sir. So it was a wonderful to be the part of this particular with a particular hands-on session as well. So thank you. Thanks a lot for joining.
Welcome, sir. Thank you.